It's recording. So we went to Ensemble and we clicked on humans and we typed in DLX1, and so now we're going to gene, clicking on Homo sapien. We get this screen, we click on DLX1. Now here we're going to scroll down, and this is essentially going to show us where they pick up, leave off, what's going on, the introns, exons, that's where the exons are. And the only ones that seem to have coding of known origin, coding sequences, are DLX1001 and DLX1002. So what we're going to do is we're going to take CCDS2247, and we are going to click on that, and we are going to take the whole sequence, not just the blue part, the whole thing. And so we take that, Control C, and we're actually going to go to BLAST at NCBI's website, because Ensemble is just to show us if there are variants. That's the only point that we're going on Ensemble, is to find out where the variants are, if there are any variants. And so now we're going to click on the human for BLAST, and we get to this screen. We're going to make it FASTA format, and so I can differentiate which one's which. Where's that key? We're gonna type in CCDS 2247. 2247. Hit enter, and then we're gonna paste the thing in there. There was an option. Where did it go? There was an option. It just said it on here too. To compare to. We'll just hit BLAST on that. I know this isn't the answer, but it'll let you go back and blast it against something else. And so these are the ones that it came up, and they're all identical. Isoform 1, isoform 2, and so we're gonna go back to BLAST and BLAST. Here we go. Align 2 or more sequences. That's what I was looking for. So we hit Control V, and I'm just gonna label this CCDS 2247, and then I'm going to go back to this screen, click on the other coding sequence, scroll down, highlight that. Okay, this is really hard though. Highlight, Control C that, go back to the BLAST website, hit V, Control V to copy, and then we will hit Shift and give this one a name, CCDS 33328. And then now that we have that, we hit BLAST, and now we get to the screen, and this is telling us that these are almost identical, but if we hit dot matrix view, we get this, and that they're identical up until this point, and then there's a gap, and then it picks up again to be identical. And so Dr. Bremer had explained that that gap is due to this. That if these are the two we're comparing, these are more or less identical, and these are more or less identical, but the difference between this and this is that little gap. So this is what they don't share. This is the two things that they do not share, and that's why we have that gap. And thank you. Okay, we are back. Now we are going to do DLX2. The first one was DLX1. So now we're going to go to Ensemble using Google. We're going to click on Human. We're going to go to DLX2, hit Enter. We'll get this screen. Click on Gene, Homo sapien, and then click on that. And now we only have one for DLX, one coding strand. So why don't we compare what the difference is? Now, DLX1 down here, DLX201 and DLX202, they are very different in that DLX2 does not have that middle exon. And it seems like the beginning of DLX201 is bigger, but we don't have a coding sequence for DLX202, so we can't really do a blast against it to see how similar they are, and that's why I think that's why DLX2 is only find it in Uniprot. So now we're gonna go to Uniprot, and we're gonna find DLX2. Well, what we'll do first is we will click on CCDS2, and we will get the translated sequence in protein language, and we're going to copy that, and then we're going to go to Uniprot through Google, because it's going to take us right there, and let's click on Uniprot here. And so then we are going to do a blast on the sequence. We're going to hit blast, and it's going to it's been running for 7 seconds, 8 seconds, 9 seconds, 10 seconds. Okay, we're just going to let it run. So, I'm going to save battery here, we're going to let it run. Okay, so we're actually going off of Megan's computer now, and this is what we're coming up with, and it is showing a brief description of the matches, and if you just want to scroll down. Okay. And we can go into detail, further analysis, and it just shows you where all the least to most in all these other species. And we'll connect.